Hello and welcome back to compiler programming. In the last video, I outlined the rough roadmap to where we want to go with instruction encoding. And as a first step, I would like to start bridging what we have here in x86 assembly variants of the operands with what we have in our instruction encoding. This is also brings us one step closer to being able to generate this stuff from these tables, which is going to be very nice. Okay, so the thing I want to do is I want to actually just make sure that we have all of these values here encoded somehow. They don't necessarily need to be one-to-one mapping, in the sense that I'm not sure I will actually keep immediate 8 and immediate 32 and whatever. I think I will instead like split this up into a type and a size, but I do want to have an explicit way to map one to another. So let's start with that. The first thing I will do is I will create a new struct, which is going to be called Operand Encoding. Encoding. This encoding will have this type, and so now I would have this renamed to operand, and this will be operand encoding. Since this is already instruction encoding, I think naming the operand encodings will be a bit redundant. Anyhow, this is the operand encoding type, which is this thing, and then we also want to have operand size. Now, it might actually be better to turn operand size into an enum, maybe, because there are only so many sizes that these instructions can operate on, and maybe that would be a generally better way. So let's do that and see how it feels like when we actually use it. Operand byte or operand size. I say operand size 8, operand size 16, operand size 32, 64, and there are actually 128 operands, but I guess we will ignore that part for now. Okay, so we have operand size, or maybe just say size, that's fine. Okay, now that we have that, the encoding types are gonna change slightly. So we would have, I also think that I will not, just considering if I should still have register memory or just saying memory is okay, and then we duplicate it, but probably not, because RM has a very specific meaning, x86 encoding. So I think I will keep this around, but I will get rid of register memory 8, and I will get rid of these immediates. I will also probably get rid of operand size in here. Where was it? Type. Operand direct. Yeah, so there was this byte size here, and I think now it will just be folded into into the encoding somehow. Yeah, I'm not sure we want it here, but maybe we do. Let's see how it goes. Okay, But I do want to just remove that and say that, okay, we have this stuff, and it also should slightly simplify our matching stuff in here, right? I think this would be slightly better and more robust at the same time, which is always a win. I'm not going to introduce new functionality for this video, so I'm just going to do this refactoring and see that all the tests are still passing, so we are still doing the right thing. Now, if I try to run this now, it's going to be a disaster and everything is broken and we have lots of issues. I'm not actually sure what this one complains about, but we will see. Okay. Anyhow, one thing that I would like to do is make this stuff slightly closer to each other, how it looks like. So maybe we also want to introduce a macro that will kind of create this for us. Or maybe not. I'm not sure. Let's see how bad it is to actually deal with it. So now it's not operand encoding types. It is it's actually saying no. Maybe that's I should put operand encodings. Because we have operands here, but these are for the instructions. Oh, maybe operands is fine. Okay. Operands, and now they consist out of two parts. One is encoding type, and the other one is the size. And it means that we will need to include more here, like where previously, for example, we're looking at this 89R here, and this is what we're looking at here as well. But previously, these three things, they would be collapsed into one encoding here in the list, and it was pretty convenient because we didn't have to kind of copy paste a bunch of stuff. But on the other hand, it also means that if there are some combinations that are not allowed, we did not really have a way to say that, and that's pretty bad because it will eventually lead to broken code. So the new code will be slightly more verbose, but instead if we introduce macros and if we do or we do automatic generation, then it's not going to be really a big issue for us. For now, let's just say Operand Size 16, and maybe I will start defining these macros. So this will be called RM16, and it's just this stuff. Then I have RM32, which is going to be this. Then I have RM64, which is going to be obviously 64, and we do have RM8 in certain cases as well. So this is fine. I will even define R for this specific file to be operand encoding. Actually, it's going to be still R something, so it's going to be R8, R16, and so on and so forth. So let's do that. Let's say that this is 8, and instead of register memory, it is just memory. And then we have 16, and then we have 32, and then we have 64, 16, 32, 64. Okay. This probably can be just 0. And that's something actually I wanted to check, like, can we drop these nonce from this encoding? Like, what is the standard actually say about this kind of initialization? Is it guaranteed to be 0 or not? So let's do, for that we will need to have a struct with 2 fields and say type def struct foo, and then I say int x, int x, int y. Actually, this should be tc, I believe. Yeah. This just changes it into mode where it treats this file as C, even though I can't select C there. So we say foo. Now I say dot y is 32, and I return foo.x, and if it says that it's 0, then yeah. So it looks like it is guaranteed to be initialized to 0 in this case. Otherwise, it wouldn't have allowed this, I believe. We can also remove ox and see if it explicitly does initialize it to 0. So this is the line that maps. Yeah. I don't think they would do this unless it was required by the standard. Okay. No, that just means that it's easy for us and we don't need these nonce over here. It will be automatically 0, and operands will now be kind of nice. So we say rm32 r32. That's pretty neat. Okay. Let's see how it feels like about that. It's not. I decided to do this. Actually, I think I will remove this underscore from here. Okay. Now that's nice. Maybe we can define another macro that will just help us deal with this stuff. So for opcode, I guess I will continue to have two bytes here, and but the extension type is something that may be nice if we could avoid typing in, instead have expanded somehow. So let's just say encoding what it will accept. It will accept coding coding. So we have opcode bytes, and then we have extension type, and we have operands. Actually, for the operands, I just want to probably do this to allow any number of them, and this will now be this stuff. So like so, and now we can actually not sure if I will be able to do it that way. Maybe what I will do is I will just write it out as a single hex value and do the shuffling here. So code EU16, and this is what it will look like. So because it's little endian, they will be flipped around, and I will need to say that this stuff is opcode and what is it? 0xff, like so. And this stuff should actually be a few, I guess. And here we take the opcode, we move it by a byte, and to be safe, we also end it with, so create a mask that just extracts 1 byte. So now I believe I can write it just like this, and it should work out. So if I do encoding 89, then I will do like _r to signify this. So I just translate all the slashes here into underscores, and this is consistent with how I did here in RM8, 16, and so forth. So we have encoding 89/r, and this is going to be RM16, R16. This looks pretty good to me. It is pretty readable compared to, like, you can see the correspondence, and even though we will now have this expanded option where we have 64, it is still gonna be fine. So let's see how we did. We still need to define this _r to be extension type register, I guess. Or maybe not. Maybe actually I want it to be this whole thing, and the reason is then we will be able to express like extension codes like this /0 as another macro that will just expand to different things. I think I like that more. So this is gonna be this stuff, and here we just say extension type, and then it will expand to 1 or 2 fields depending on the extension type that we have. So this looks good to me. Okay, let's see what happens. Well, it doesn't complain about this stuff, so at least we compiled it correctly, or like we expanded the macro correctly, but there's still a bunch of stuff to do. Okay, so we have 89 that is in this direction. I believe 8b is just in the opposite direction, and yeah, 8b is just in the opposite direction of encoding. So we have, should I do this? Like, think like this is the easiest. Okay, this looks neat, I think. Now we have a register memory and immediate 8. So this is where we'll need to clean up all of these. Like I define these macros, and for example, I will also define a macro called immediate, probably just immediate, or maybe immediate and then number. and we have the same functions in value.c. It would be nice if they don't interact with each other, don't overlap. So at the end of this file, I will actually undefine all of these macros. So it's gonna be nice and tidy. Okay, getting back to this, we have another thing which requires us to change the macro, and this is like what I mentioned, that we need slash ext, even I will call it full thing, Opcode Extension, or maybe not. I don't know how to best deal with this. Yeah, I will do it like this. Ext is 0, and now we need to create one. We say ext, and it accepts byte, or not even a byte, I guess it's basically 3 bits. I guess 3 bits, or maybe we could just call it extension. And this one I will split over 2 lines, so it is slightly easier to read, and it's gonna be Opcode Extension. So it's gonna be like so and like so. And here I will also make it slightly easier on myself and do and be 111. So like this number here, it can never be larger than 7 because it is encoded into one of the mod RM bytes, and it just is expected to be that. Extension type is now different. It is extension type opcode. So that looks good to me. To do the same thing where we say, actually it is RM, 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 and then 16, 32, 64, that's good. And we have immediate 8. Actually, I will do like this. Immediate 8, immediate 32, and then immediate 32, I believe. Yeah. So this is already one of those points where it's just nice if we can directly encode this mismatch, that you don't have immediate 64 here. Previously it was a bit hacky the way we dealt with this. So that's good. C6, C6, C6. It's good. Now we have C7. Actually, no. C6 was wrong. C6 was about immediate 8. So it's actually good that I did this. Rechecked. So this is now C7. And C7 is what? It is 16, 32, 32. Yeah, so C6 is 8 and C7 is 16, 32, 32. This is how it is. That's good. Now we have B8, and B8 is moving from register, from immediate to a register, and this one does allow to have 64-bit operands. This is why it is here. So let's just say we'll take these 3. We'll say B8, B8, and B8. And then this is going to be just register. This is incorrect. This here supposed to be RM8, I guess. Wait, C6. Yeah, this is 8. This is 16, 32, and 64. Okay. So this is 16, 32, 64. Immediate 16, 32, 64. So I need to look at this stuff. Extension type is none. So I will just say like so. And this is actually quite interesting. So previously, the way I encoded this particular stuff, where you specify target register by just adding it to the opcode, it was part of these encoding types. But if we want closer correspondence between these two, then sort of the operand is still register. It is kind of extension type is different, I guess. So this is another change that we will need to do. So yeah, it's gonna be should be type plus register, and we remove this one from here. So let's do it this way. And this we will call plus R. Extension type will be extension type plus register. Okay, so this is what it's going to be. This is good now. And here it can actually accept a 64-bit immediate. It's good. We did not define immediates though, so that's the next thing that needs to happen. And I will make them consistent with how we do with registered. So im, and im. This is gonna be like this, like this, like this, like this. Okay. 8, 16, 64, that's fine. That's good. Looks okay. Now we can continue. So let's try to build this. Okay, move seems to be perfectly happy with our setup. Can even space it out slightly so it is easier to read for us for now. I like how that looks like. And let's continue. Move SX, I think I will just remove it because we're not really using it yet. And it will be easier to refactor if we're not using it. Okay, Leah. That is gonna be a new stuff because we don't really have something like this before. The extension type is _R. It accepts a register. And yeah, so this is quite interesting. Because I'm not exactly certain what is going to happen if I try to store it in non-64-bit address. So for now, just ignore this and just add only one encoding that says you can only store it in in 64 bits. So we need to also define M. And this is an interesting thing because Leah actually does not care what is the target size, but I'm not sure. I'm not sure what's the best way to handle here. One thing I can do is I can say Operand Size any, and just like have this special case to verify. Another option would be to have all of them there. Like, doesn't really matter what is the size of it. So like I will list all 4 options, and then when we get to vectors, then we do something. I think I like that option more, to be honest, than other stuff. So I will create this thing, and this is gonna be memory, and memory. And I will just kind of explode all the options. 16, 32, 64. Okay. We have Leah. We have now want to have return. And actually I'm doing the wrong thing here because I'm not adding args in here. So, which actually will do the wrong thing, probably because they will yeah, this is not really great. I'm not sure what this macro will expand to in the end, because if this is args, it might add a comma here, and it means that the first operand will actually be nothing, which is not what I want to have. Maybe I can do it like this. Define encoding operands, and I believe if I do it with an extra stuff it will be fine, but I'm not certain as well. Let's try it out like this though. Let's see. Okay. So here we want to have encoding that is 0x3. The extension type is, I think, doesn't exist. It's none. Yeah, there is no really extension type here. So it's going to be 0. And for we don't have any operands, so it's just going to be like this. Let's see how it feels about that. It is not really happy with it, but I will come back to this later and see what's actually wrong. I think it is this whole vararg stuff. Now there is another way how you can have macros with different size of like overloading based on number of arguments, so we can just use that one. But for now I'll continue here. Inc, that should be pretty straightforward. We just say ff, extension type opcode, so it's going to be ext. I think I have to call it opcode Yeah, I think Opcode is better. Opcode. This can be called Opcode. Okay, Opcode is 0 and it accepts RM. What exactly? So F0 is standard 163264. It's fine, we can do that. Okay. Looking good. Now we have add. Let's open the page right away so that we don't do something weird. I bet this one is going to be a register. It's probably going to be something like this. This is good. We have 03. It is register and register memory. So as you can see, once we have this macros defined, it's just much more straightforward what it actually does. Let's recheck. Where's our 03? And it is this stuff. Looks perfectly fine to me. So let's get rid of that one. The next one is 83, and 83 allows us to add a byte to this stuff. Again, this is where the new encoding is kind of nice. Here say immediate 8. Oops. Immediate 8, I said. Immediate 8 and immediate 8. So this is, again, this instruction encoding. And now we need to update the opcode. Good. And finally, we have 81, which is a more standard version of this. I will actually put it over here. And here we have 16, 32, and 32. That's good. Let's see. Okay, seems to be compiling just fine. And now the same will gonna happen to the sub, which is fine. We can do that. Let's copy the base thing. Extension type is register, but this is actually other way around, but this is matching this one. So register and register memory. Let's go to sub and recheck everything. So this is 2B, and 2B is R and RM, and this is exactly what we want. So we take this, and now we will flip them around. So it is gonna be this, and this is gonna be 29. Pretty easy. Now we have 83, and this is immediate 8. So I will take this stuff. I will put it here, and here I will say opcode of 5. Oops. 5. It targets register memory, and on the right side is immediate. This is this one. That's good. Okay. The next one is 81. They're also in the wrong order again. So it's also 5, but on the right side we have standard 16, 32, 32. And they are just basically more or less mirrors of each other here. /5. Good. I move, and this is the first one that has actually 2-byte encoding that we are gonna deal with. We need this one. And we just merge these two now. We can do it like this. XFIF, instruction type register, register memory. That seems very good to me. Go check out IMO, verify that 0IFF, it's this version, and this is what we want. That sounds great. Get rid of this one, and then we have register, register memory, and immediate 32. So this is that version with 3 operands. I believe this is the only instruction that we actually use 3 operands for. Okay, so it is gonna be like this, more or less. Except I guess here goes the register, and here is 69, and on the right side, yeah. So, but we also need the register part. So it's like this. Good. Can continue. Okay. Operand encoding types is this. It's IDIV. Let's jump to IDIV over here and see what we need to do. So this is F77. It is this version, and it just has an implicit operand. And this is kind of interesting. I think we would want to have this encoded as well, maybe. But let's see how it goes later. For now, I will just re-encode what we have already. Okay, so it is, let's just take this version. It only takes 1 operand. Okay, that's fine. It's F7, and it has opcode, which is 7. Okay, I believe that's all there is to IDIV. Now we have CVD, CVQ, and CQO. CVD. And this time it actually should be fine, because actually, yeah, there is no real difference with how we encoded it before, I guess. So we do this, we put it here, we say 0 and nothing. That's fine. Why was it 48? Oh, it probably is the prefix for the 16-bit version of the instruction. Yeah, okay. Makes sense. Now remember what is happening here. 6. So basically I'm encoding the rex prefix directly into the encoding. It's a bit of a hack, but it works just fine for now. So we're gonna keep this. Yeah, it's complaining, but that's because we don't deal properly with instructions that don't take any arguments. I guess I could just do (0) everywhere and fix it later. Maybe that's what I do. Let's just fix this for now, because this episode will be already quite long and dull without us fixing that. Except it does not seem to be doing anything. Oh. Yeah, we can't put 0 there. We need to say none, I guess. Extension type none, because otherwise there is a missing trailing comma. Now are you happy? Okay, so this is how it needs to look like. It's none and 0. It's not the best, but I don't want to go too much into macro fancy stuff right now. Okay, call. Call is interesting because I believe it's slightly different from other instructions as well. Let's see what happens. Yeah, so E8 actually only accepts 16 and 32 immediates, and the extension type here is none. And we have 16. Okay. And then the next one is FF2, and this is more or less standard RM stuff. So this is what we can copy from here. It's going to be FF, 2, 2, and 2. And I'm looking over here in the source or in the documentation. I have a bit less than half to go. So let's push through this. Okay. Compare. Extension type this. We have register memory and we have immediate. I believe it's going to be like this. Have 32, 64, and I bet that this is 32 is 32, but it's something we should verify because you never know. 81, 7, yeah, 16, 32, 32. So this one is done, and the next one is this one, is 3B. It's here, and this is R16 and then RM. So I guess I will do it like this. Good. G and Z is next on the list. And this one actually only takes immediate 8, so there isn't even okay. And the other one is taking a 32-bit immediate. So it looks like this. Okay, looks good to me. Is it 5? Just to verify. GNZ, JCC. 0F85. GNZ, yeah, 0F85. Okay, that's fine. Now we have JZ, which is exactly as JNZ, except it's 84. And then we have setz, which is also close by to those ones. In reality, we'll probably create another macro that will create all of these ones for us. So, or maybe we'll generate them. I don't know. Okay, and setz. Let's copy this one, except it points to RM8 and it wants 94. So it's sets a byte in a register or memory. Then set L is exactly the same, and except it's different opcode. But now we can actually get rid of this to do because we are explicitly saying we're only operating on a byte. So that's good. Let's continue. Set G is the same but with 9f. Almost there. Have a jump. Jump is EB and immediate 8, and then it has another form which is E9 and immediate 32. So this is good. And we are done with this file. Oh, that's good. We have all the instructions in new format. I quite like it. As I said, now we need to clean up after ourselves and take all of this stuff, go to the bottom of this file and do undef of everything we defined at the top. Okay. And like so, like so, like so, like so, and continue like that. Okay. Almost done. And good. Cool. And also reduce the amount of errors because, as I said, immediate 8, 16, and 32 are overlapping something else. So it's good to do this cleanup. Okay, now we need to change how this works. This is gonna be the biggest change that we're making today. Operand encoding. This is gonna be called operand index. Encoding type is undeclared. What is wrong here? First of all, let's just say that this is going to be like this. Encoding operands. What is encoding? Encoding is instruction encoding. Let's go back to instruction.c and verify that that's how it is. Yeah, it is. It is called operands. So what is wrong here? I'm not exactly sure. Maybe let's see the full output. Operands is not a member of operand encoding. Operands is not a member of operand encoding. Encoding list index. Yeah. Wait, what? Oh, okay. Yeah. should be like this. Good. Now we need to figure out what is the right way to do it. So the first one stays the same. We have operand instruction, operand, so operand encoding type. Okay. Let's first just replace this stuff like this, which will resolve some of them, but not all. First of all, we don't really need this, but I will just comment it out and add a fix me so I don't forget about this, because now this needs to be handled in the encoding below. So we change this, remember, to be an extension type instead of a way to encode the operand. So this is good. These ones technically stay the same, but we need to have another fix me check types for check sizes for register and memory operands. But this one we already need to check, otherwise everything is just gonna explode horrifically. So if operand type is immediate 8 and operand encoding is so I will change this slightly to say if operand encoding type is immediate, and then do like this: if operand type is immediate 8 and operand encoding size is operand size 8, then continue. The same for 16 and 32. I'm not sure we even have 32, 16, so I'll skip this for now. 32 and 64. Just shorten this slightly. Okay, so this should take care of the immediates. Making progress. Just have 2 left. Okay. The encoding type here is so this stuff now goes actually into here, and it's not encoding type, it is where's extension? Extension. Yeah, we can assert right away that this is not an... Wait, just a second, how it was before? Yeah, so we can assert that it is not an opcode, but then we want to say if extension type is instruction extension type plus register, I believe it's called, then we do something, otherwise we do something else. So now we handle it like, right, else. So we take this step and we put it over here. Okay, yeah. That's fine. Encoding, yeah, so now it's called operand encoding, And this is Operand encoding type. Okay, that's good. That stays the same. Different const qualifiers. Okay, that's okay. We can add a const qualifier to it. Okay, so that was a lot of changes. Let's see how terribly it all explodes. Well, that's good, I guess. And we have instruction type is not opcode. Well, yeah, because I guess now this should go into here. Let's see if that helps. No, not really. Interesting. Instruction extension type opcode. Okay, let's fire up the debugger and see what is going on. Defenv mess. Let's run this. Okay. Encoding. So which instruction are you trying to encode? Encoding, opcode, operands. So this is Opcode Extension 7. You can probably just search for 7 and see which one is this. 7. Oh, like this. I probably screwed up the compare and didn't even notice. '81 and 3B. Yeah. So this is screwed up. And probably this is why it is complaining. So 81 indeed has this /7, but this one doesn't. Okay. Stop this, rebuild this, and run this. Cool. So looks like that's it. We have all the tests passing. We have this new approach, which makes me pretty happy. And I said, like, all of this is first of all more robust. Now we are closer to what we have here, which means it will be easier to generate this automatically, and in general just a better system, I'd say. Now, one final touch that I want to try, I will not necessarily fix the errors if they happen, and they probably will happen, but I will try to get rid of this fix me and actually say, no, this is not working. I can here add match end. This is just allows me to, maybe I can do just break early. So what I want to do is say if operand, where are you? Operand index, have operand encoding, and we have operand type, but I want to have operand as well, because I will want to take a look at its byte size. Okay, let's do it this way. Now we can, technically don't even need this, we can replace it with operand type. Okay. Good. And what if I do assert here? Maybe not assert. No, it shouldn't be assert. It should be if parent byte size is not the same as let me change this out to say 1, 2, 4, and 8. This just would be make it easier to compare this, and I would say U32 of operand encoding size match is false and break. Yeah, that sounds good to me. And this will probably cause a bunch of errors. I will not fix them, I guess, but I'll not fix them on stream. Yeah, so this is kind of just shows that we still have a bunch of robustness to deal with. I will probably do this video, but that will be enough for today. If you survived this far, then I thank you very much for watching and see you next time.